So now we're doing actually solving. We're actually solving exponential. Solving exponential. And so when we're solving exponential, what we want to do is get the bases the same and make sure there's only one base on each side. To do that, we always have to go down, not up. So we have to think of the smallest number I can rewrite with an exponent that is going to give me that value. It's kind of always easier to see it with the smallest value. So I know 36 can be rewritten as 6 squared. What can 216 be rewritten as? 6 to the third power. You keep your original exponent. You keep your original exponent in parentheses. Once you have done that, once you have that part done, you can just get rid of the base and make it linear. Remember, whatever I do on one side, I can do on the other. As long as my bases are the same, I can get rid of that same base. And that's going to be 3 parentheses r minus 1. We got to scroll out just a little bit here. Equals 2. You set that equal to that. From there, it is a linear equation. 3r minus 3 equals 2. Add 3 to each side. 3r equals 5. Divide each side by 3. R equals 5/3. Now, I told you before that don't be surprised when you get an exponent answer on one of these. Okay? Now let's move on to number 13, which has worked almost the same way, but I mean 15. I said 13 was worked also the same way. So the difference with 15 is, actually there's not one. You still have to bring them both down. You may have had trouble figuring out what the smallest base was. Guys, the base is always going to be the same number for the most part. It's going to be a number 2 through 7. They're not going to normally go bigger than that. All right? So in this particular case, what would your base have been? 4. Because on the left side, that's going to give me 4 squared. Put your original in parentheses. And on the right side, it's going to give you 4 to the third. Put your original in parentheses. Oh, I know why this one was asked. This one is a little. This was a good one to do. We've talked about this before, so you may want to put a star by this so that you don't forget it. Once I have done what I've just done there, all I have to do, again, is drop the base. It was all about the base. That wasn't even an intentional joke. So that's going to give me 2 times 3b equals 3 times negative b, which is going to tell me that 6b equals negative 3b. What students always try to do here is divide each side. That's not going to get you the right side because there's a rule that says I can only divide when I have all my variables together on one side. Don't divide when variables are on both sides. It's ugly. So I'm going to add 3b so it can be on the variable side of the island. That's going to give me 9b equals 0, which means b must equal. All right. We've done it before, but it's tricky, right? There's something about it you just want to divide. You know why it is? You see one term on each side. That's why you want to. That's exactly why you want to. All right. The next one we're going to do. Yes? That will only be true if you don't have another number involved.
Yeah,
that is true, yes. Anytime, guys, think about it for just a second. This is what she was asking me, and it was an amazingly good question. So let's take that from a higher level standpoint. What is the only number in the world that can make this true? 0. There is no other number you can multiply by one number and a different number and make them equal. If I take 1/2, that's, I mean, any fraction, you know what I'm saying? Those values have to be different. The only one that's going to work is that 0 because it's special. Because it makes everything become 0, right? It's got that golden touch. All right, that was a great question. Yes, you should be able to see that. All right, next one. Number 19. For the purposes of your quiz next class, one like 19 would be considered extra credit. But you know that if you can figure out how to do it, that's a point that you would get that would help bring up your average. So, the first thing we have to do is make them all the same base, which in this case, is it going to be 3?
Yeah.
All right. So I'm going to rewrite the first one as 3 squared, original exponent in parentheses, times 3 to the 4th, original exponent in parentheses, equals 343 is 3 to what power? 6, 5th, that's what I thought it was 5th, to the 2v minus 1. Again, all of my originals are in parentheses. Now, before I can drop that base, I have to have only one base. All right? If you think about it, it is true. You only have one baseline, right? You can have different things going on in it, but you have one baseline. So, what is the rule that says when I'm multiplying and I have the same base, what can I do? I'm going to add. So I'm going to rewrite that as 3 to the 2, 3v plus 1, sorry, that's a 3, v plus 1, plus 4 to the 2 minus 3v, oh my goodness, equals 3 to the 5, 2v minus 1. Boy, that thing is ugly. But now that I have one base on each side, what can I do? Drop that base. Drop the base. We're going to set this equal to that. So I can go ahead and distribute out, right? So I'm going to say 6v plus 2 plus 8 minus 12v equals, we drop the base, 10v minus 5. How about we combine some like terms, because that's getting awfully ugly. 6 minus 12v is negative 6v. 2 and 8 is 10. Yes, I can. Thank you for letting me know. Equals 10v minus 5. Now, I want variables on one side. It doesn't matter which way you do this. I'm going to personally add 6v to each side. That's going to give me 10 equals 16v minus 5. Then I'm going to add 5. It's a long problem. 16v equals 15. What's my last step? Divide each side by 16, and so v equals 15 over 16. Now, I want you to realize that this problem, that's why it's extra credit, it will take longer. It will take longer, because first you had to do all the exponent stuff. Then you had to do all the linear stuff. It is beautiful. It is gorgeous. Yes, ma'am?
Why is that 6 negative? Yeah, that's 6v.
6v minus 12v was negative v when I combined like terms. Great question, though. That's exactly where you should have asked me that. That was a perfectly asked mathematical question. All right, one more problem. One more problem. And that's the division one. Guys, this one was not as bad as you thought, but it did look different from anything else we've done. And sometimes that could throw us. Some of you wanted to simplify the 4 and the 8. Why can't I do that?
Because they're not the same.
Why can't I just say 4/8 is 1 over 2?
Because
I can't simplify when I have exponents. Right? I can't do that. So I need to make everything the same base. And what's the only number that's going to work here? 2. So I'm going to rewrite everything with a 2. That gives me 2 squared, the original one in parentheses, over 2 to the 3rd, original one in parentheses, equals 2 to the 5th, original in parentheses. Now, the problem here is I have a different rule going into place. What does my rule say when I've got the same but I'm dividing? Subtract. So that's going to give me 2. Now this is very important. To the negative 6n, I went ahead and distributed that out, minus 6n. Right? Minus those two multiplied. Equals 2 to the 15n plus 5. I just did 2 steps together. If that's too much for you, don't do it. Yes, Nicole? Oh, I mean, strange student, I don't know. Shh. No one needs you to be counting.
Why doesn't the 2, like the 2 and 5 and 2 and 5, shouldn't that become 1 if you divide?
Cannot when they have exponents like that. You can't do that. You can't do it when they have exponents. It makes it different. That's a great question, though. Yes, ma'am. All right. So I did an in-between step there, and I'm just going to write it out just in case, because I probably should have anyway. And that in-between step that I did was if I have the same base and I'm dividing, I can subtract. So I said that means that I've got 2 to the 2 minus 3n minus the second exponent 3 times 2 to the n equals 2 to the 5, 3n plus 1. Then distribute out. Now I'm going to set, yes, 2 to the 5th is 32. I'm replacing 2 to the 5th with 32. All right. Then it's just a matter of setting these two equal to each other. That's negative 6n minus 6n is negative 12n equals 15n plus 5. This one's going to just be easier to subtract 15n on each side. And that's going to give me negative 27n equals 5. Divide each side by negative 27. And n is going to equal this really ugly fraction that happens to be the right answer. Remember to expect some ugly looking answers with these. Now, that last